Hi all. This particular problem which appears in JEE Main, right, where it says that we have to find the point of discontinuity, right? That's the first objective, right? Now see that here we have to think twice before going ahead, right? Why? Because in the given function we are having the greatest integer function, we are having the mod function together, right? So first we open it by one, right? So here we first see that what is our mod x, right? Now mod x is, see that our main domain of interest is actually the closed interval minus 1 to 3, and the mod x will change x less than 0, x greater than 0. So that's why the function definition need to be modified little bit. Okay, let's see that. Okay, now we first start with that mod function, right? So we'll say that mod x is equal to plus minus x, right? When your values will become minus 1 less than equal to x less than 0, and it's equal to x when 0 less than equal to x less than 1, right? Now obviously, right, the definition will be less than, greater than, equal to 0, less than, equal to 0, but as we are looking for that only the function in this domain, right, so that's why I wrote it in only in this form. Okay, now see that if it is true, so therefore my fx, right, we can easily write down that as what happened, it is minus 1 less than equal to x less than 0, and we are having the second condition that 0 less than equal to x less than 1, right? So this is the two definition we need to calculate. So first we have x minus x, here we have plus x. Okay, now we have box x, right? Now to find the box x or the greatest integer function, let's draw the number line, right? Always do that. Okay, if you are well good enough, so you can directly apply that. So see, we are having minus 1, 0 and 1, right? Now when we have our case at minus 1 to 0, so therefore in this region, right, in this region the greatest integer less than of that will be minus 1. So therefore we'll say that it will gives you minus x minus 1, right? So let's write down that. So therefore it will minus x minus 1. When our function value is 0 to 1, that means in this region, right, in that region obviously we'll say that it is between 0 to 1, so the greatest integer is 0. So therefore we write it as 0. Okay, now we go for the next case, 1 to 2. Okay, so between 1 to 2 we can say your function value is gives me that x plus x, that gives me that 1 less than equal to x less than 2. Okay, so now we see that only one condition is left, that is that 2 to 3, right? So see that if I go ahead and try to understand this 2 to 3 case, right, let's go ahead and see that. So we'll have that 2 less than equal to x less than 3 now. Okay, so between 2 to 3, let's draw the number line and put it as 2 to 3. And so therefore what is the case of that greatest integer function? Greatest integer function will be equal to somewhere in this interval, so therefore the less than value will be 2, right? So this value gives me x plus 2. That's it. Now we need to calculate at x equal to 3 as well. So this is the importance. If we write it as x less than equal to 3, we'll face issues. Why? Because that greatest integer function at 3 will change the value, right? So that's why the function will take x plus 3 when it is beyond 3, right? So 3 plus something, right? So now see that here at x equal to 3, obviously you'll see that 3 plus 3, that's equal to 6, right? So that's it. Okay, so now see that here, why should I write it in the form of 2x, right? So why we write it as x plus x, so makes it as 2x. So that's the exact definition of the function that we are looking for, right? Now see that we need to find out at which point, right, these are discontinuous. So see that obviously function is continuous inside each and every interval, right? In that minus 1, in minus 1 to 3, each and every point it is continuous, except we don't know at the point 0, 1, 2 and 3. So this point is the doubtable point. So you have to test at only these 0, 1, 2, 3 points, right? Let's go ahead. So let's test it for one by one. So first we calculate limit x tends to 0 minus fx. So 0 minus fx. So your function value will be definitely follow this statement, right? So therefore we'll say that its limit x tends to 0 will have minus x minus 1, and that's why it's minus 1. Limit x tends to 0 plus fx. So that will follow the definition x. So that gives me that limit x tends to 0. Limit x tends to 0 x, that gives me 0, right? And also notice that f0 is equal to 0. That means that fx discontinuous at x equal to 0. So that's it. So at x equal to 0, the function is discontinuous, right? Now we have to test for the discontinuity at x equal to 1 point, right? Okay, so let's test that x equal to 1 as well. So see that limit x tends to 1 minus fx, that becomes limit x tends to 1, x 1 minus, that gives me actually x, that gives me 1. Limit x tends to 1 plus fx, that gives me limit x tends to 1 plus, that gives me 2x. Definition, that gives me 2, and f of 1 is equal to 2. That's imply that discontinuous at 1. Okay, let's go ahead and test for 2 minus. So limit x tends to 2 minus fx, that's equal to limit x tends to 2. 2 minus means we have to use the definition of 2x, that's 4. If I go ahead and find that limit x tends to 2 plus fx, we'll say that it is limit x tends to 2. 2 plus fx, right? So for 2 plus fx, we'll see that the function value is became x plus 3. Now here, okay, see that I wrote it as x plus 3, but obviously as we mentioned, that became x plus 2 obviously, okay. Now come back to that number line again. In that number line, right, you'll see that we are talking about this 2 to 3 interval. Now any number less than that 3 or between 2 to 3, obviously the mod box function, whatever is given here, that actually 2. So that's why it should be x plus 2, and that's why this cannot be 3, that is 2. Okay, that's it. I just made that small error, so that's it. Now let's go ahead. So therefore it's became again 4, and if I calculate f of 2, that also obviously 4 without any doubt. So that's why we'll say that continuous at x is equal to 2. So we are having 1, 2 discontinuous, 1 continuous. Now only one problem is left, right? So by visualization only we can say that at x equal to 3, the function is discontinuous. Okay, why? Because see that here, that limit x tends to 3 minus fx, right? That gives you as limit x tends to 3 fx, that means x plus 2, and that gives me 5. Limit x tends to 3 plus fx. It's the problem is I don't know how to calculate that x plus 3. Why? Because at that x plus 3, the function is not defined. X tends to 3 plus, the function is not defined, okay? At least for this case, right? So it is not true. And also see that if I make our life little simple and calculate f3, so f3 is equal to 6. So obviously these two values are undefined. So we can also say that discontinuous at x is equal to 3 as well. So therefore, for this problem, obviously see that it is only discontinuous at the point x equal to 1, 0 and 3, okay, these 3 points, and that's it. So only the case is that for this problem we have to rewrite the function in this form, right? If we able to write down that, you don't have to go ahead in this technique, right? This is the general way of writing it in any other broad exam, where you have to give some explanation, then mathematically we have to explain it. But for MCQ type problem, it's not that difficult, right? Except few cases. See that we just test the function value at always in the point wherever we have a doubtful point, where the function changes definition at that point, right? See that at x equal to 0, it's -1. X equal to 1, you just substitute here. So we are testing at 0, right? Use these two definition, -1, 0, not equal, discontinuous. Test for that this definition, 1 and 4, 1 and 2 not equal, so not continuous. Use these two definition at 2, 4, 4 continuous. See that 6 and 5 not continuous. So that's the one of the easiest way to check, right, the function's continuity and discontinuity. But yes, some cases tricks may not work, right, because that's not the generalized mathematical technique to find the continuity, right? But 99% cases it will work. Okay, that's it. Hope you understood the problem. Thank you.